In the previous lecture, we discussed arithmetic sequences in detail, which are sequences constructed by adding a fixed number to each term to get to the next term. In this video, we will be introducing geometric sequences, which are very similar to arithmetic sequences. Let's look at a particular sequence, 2, 6, 18, 54. This is not arithmetic because the difference between terms is not constant here. So in this instance, the difference is 4, but in this instance, the distance is 12. However, the ratio between successive terms is constant. So in this case, the ratio is 3. And in this case, the ratio is also 3. And here the ratio is also 3. We call such sequences geometric. The recursive definition for the geometric sequence with initial term A and common ratio R, and I'll write that out too for you. A is the initial term. So in that instance, A would be 2. And then R is the ratio between consecutive terms. So that would be 3 in this instant. The recursive definition would be AN equals AN minus 1 times R. We're multiplying each term by a common ratio R to get to the next term. And the initial condition would be A0 equals A. Now, to get the next term, we multiply the previous term by R. We can find the closed formula like we did for the arithmetic progression. We can write A naught equals A, and then A1 would be A naught times R, which is A times R. And then A2 would be A1 times R, which is AR times R, which is AR squared. Let's do one more. A3 would be A2 times R, which is just AR squared times R, which is AR cubed. Are you noticing a pattern here? We must multiply the first term A by R a number of times, n times to be precise. So that means then that AN is just A times R to the n. Okay, so let's take a look at that definition in particular. Let me erase everything because this is an important point here. A sequence is called geometric if the ratio between successive terms is constant. Suppose the initial term A naught is A and the common ratio is R. Then we have the recursive definition AN equals R times AN minus 1 with A naught equal to A, and the closed formula is AN equals A times R to the nth power. If you look at other textbooks or online, you might find that their closed formulas for arithmetic and geometric sequences differ from the ones I showed you. Specifically, you might find the formulas, you might find AN equals A plus N minus 1 times D. And you also might find, that's for the arithmetic sequences, and then for geometric, you might find AN equals A times R to the N minus 1. Which is geometric. Which one is correct though? Which closed formula is correct here? Well, technically both. In our case, we take A to be A naught, A0. If instead we had A1 as our initial term, we would get the slightly more complicated version of the closed formula. And so for that reason, that's kind of why we start with n equals 0, is because it makes the formulas a little bit cleaner. Again, they're both correct. Just be careful if you're working with another discrete math course while you're taking this course, then just keep that in mind that your formula might differ from mine depending on whether you use A0, A naught as your initial term or A1 as your initial term. Anyways, thanks everyone, and I'll see you in the next lecture.